So this is 7n. We can easily check our work. When n equals to 1, I'm looking for the first term. 7 times 1 is 7, alright. When I check, let's say term number 4, randomly choose one. When n equals to 4, term 4 equals to 7 times 4, 28. So it is correct. Okay, so this is our general term. Don't need to overthink things. Yes?
I just realized that f can be, the formula can be simplified.
You mean from 7n you can simplify it further?
No, I meant the f. The example
1f can be simplified?
Yeah.
What do you mean?
Formula.
The formula can be simplified. What do you mean by simplified?
Like you can do a
Shorter?
I mean another type.
Show me after lesson. Okay, part B. Hence. Okay, I want all of you to highlight this very important word, hence. It is a keyword, hence. So hence over here implies you must use answer from previous part. Okay? You must. So let's use the answer from the previous part. We want the 99th term. So T99 will be 7 times of 99. So 100 minus 7, no, 700 minus, okay, never mind, 99 times 7, we get 693. Okay, this is the answer. So why am I emphasizing on the word hence? What if? What if you did not manage to get the answer from part A? Or what if you didn't use the answer for part A? Is it possible to still get a correct answer? Is it still possible to get a correct answer if you didn't use what you had from part A? Can. Just keep adding 7 lah. So this is term 5, term 6, term 7, term 8, 9, 10, 11, 12. You just keep adding 7. So you'll be writing so many numbers. And then provided you are being very, very careful, when you reach term number 99, you will end up with 693. Okay? So it is still possible to get a correct answer. But I will just give you a 0, even though the answer is correct. Why? Because of the word hence. You must use the answer from the previous one. So this listing down all the numbers, you did not use the answer from part A. So you get 0 even though the answer is correct. Understand? Any questions? Okay, then let's move on. Next, example number 3. Number sequence 1, 4, 9, 16, 25. That's what I wrote, right? Oh, that was my first example. Find the general term. We've done this earlier on already. So part A, Tn. Tn is the general term. Okay, so above it, I'll write T1, T2, T3, T4, T5, dot, 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 Tn. I want to find the relationship between this little number and the actual value in the term. 2 and 4, 3 and 9, 4 and 16, 5 and 25. So in English, actually what we want to do to find, for example, 16, you just take 4 times 4, or 4 squared, 5 times 5, or 5 squared. So if it becomes n, it's simply n squared. Simply n squared. So this value is n squared. Regardless of the value of n. Just put it in, you will get the answer. So hence, again, hence, you must use the answer in part A. T27. Can you see that I'm showing the marker? I'm showing the marker, I'm writing in the same format. T27. I'm telling the marker, hey, better look carefully. I am using my answer in part A. Okay? And this is equal to 27 squared. 729. Done. Okay, next one. Whoa, what is this? 2, 8, 18, 32, 50. What is the general term? Can I find it? How about the rest? Do you know the pattern? Well, at least we can see that the numbers are getting bigger. And then we see that the numbers, they're all even numbers. Maybe we consider what happens if I divide everything by 2. You get 149, 16, 25. Oh, now it sounds familiar, right? 1, 4, 9, 16, 25. If I divide everything by 2, 1, 4, 9, 16, 25. That is if I divide by 2 lah. And then I know this sequence, isn't it? This is actually my 1 square, 2 square, 3 square, 4 square, 5 square. Then all I need to do is to just multiply by 2. By 2, multiply by 2, 2, 2 to get the answer. So it's 2 times of this, 2 times of this, 2 times of the square. Okay, very messy over here, but you get the idea. So this was my term number 1. Term number 2, term number 3, term number 4, term number 5, term n. All I needed to do was to take the n, you square it, then you multiply by 2. That is the formula. So you need to observe the pattern. Okay, this is not as straightforward, but it is still something that is manageable. And we expect you to be able to do it. So in part A, general term Tn. 2n squared. Every time I see the n, I square it and I multiply by 2. So do a quick check. What is the value of t, for example, t3? So let me check my answer. 2 times of 3 squared. 2 times of 9, that is 18. Check. Oh yes, it's correct. Okay, next. Hence find the 18th term. Part B, t18. 2 times of 18 squared. Times 2, 6, 4, 8. Next one. The first term of a sequence is 38. The following term, each following term is found by subtracting 7 from the previous term, write down the second and the third term. So in part A. Okay, first term tells us that T1 is 38. So they're asking what's T2? 38 minus 7, which is 31. And T3, subtracting 7 from the previous term. So 31 minus 7, we get 24. So we got T2 and T3 already. So write down an expression in terms of n for the n term. Tn equals to. This is a similar question that I asked you yesterday as part of your homework. I gave you a sequence, I think it was, what was it? 8, 13, 18, 23, 28, so on and so forth, right? It was a constant difference of 5. Then I asked you for the general term. It is similar to this also. There's a constant difference. It's a common difference, plus 2, plus 2, plus 2 on the board. My example yesterday was plus 5, plus 5, plus 5. This question is minus 7, minus 7, minus 7. They are all common differences. So then, how do we find out the general term? Okay, so what is your final answer for this? What do you all have? 45 minus 7n. Let me do a check. Okay, I'm not going to say whether it's right or wrong yet. I'll just do a check. Okay, let's start with the first term. Just to confirm, T1 equals to 45 minus 7. That gives me 38. Okay, looks correct. T2 equals to 38 minus 7. That is 31. Oh, okay, correct. And T3, wrong over here. 45 minus 7 times 2. So 45 minus 14, that is 31. Okay, correct. Next, in the formula, 45 minus 7 times of 3. And that is 24. Okay, it is correct. This answer, this general term is correct. But the question is, how do we get there? Yes? Okay, there is a common difference of 7. Then what do we do with that? Put it as the n. Okay, so right now what I'm trying to do with your class is we are trying to find out how we can derive this formula. Okay? So definitely subtracting 7, it has to appear over here. Look at what I had on the board. Common difference of 2. Can you see the 2n on the board? When I have a common difference, I add 2. I will end up with a 2n. When I have a common difference of minus 7, I will have a minus 7n. Yesterday's example, when I had a common difference of plus 5, we expect to see a plus 5n. Okay, now one part of it is done. The other part of the formula has a 45. Now where did that come from?
38 plus 7.
Why 38 plus 7?
But n is 1. So,
The first one? No, the first one is 38.
yeah, 38. No, I meant the 38 is the first term.
Uh-huh.
So it is, if you want a 7n, then it will be 7. Or you can like 38 minus 7n.
Okay, don't understand. Don't understand. So how do we get a 45? From what I understood from him, there is involvement of the very first term, and it also involves the same 7. Okay, think about it. How do you get a 45 from 38 and 7? How? Just add, right? 38 plus 7, we get 45, isn't it? Now look at what I have on the board. How do I go for this particular sequence? How do I go from 3 and 2, 3 being the first term, and the 2 over here, which is the constant difference? How do I end up with the second part of the formula, which is the plus 1? How? Okay, 3 minus 2 equals 1. So there's a minus over here. Whereas in this set of notes, apparently I'm supposed to take 38 plus 7. Oh, that's so confusing. What do we have to do? Is there one way for us to actually just get the answer straight away, without all the headache? Turns out there is. Okay, I will introduce you a general formula that is applicable for all common difference questions. Listen carefully, Every time you see common difference, looking like this, and your homework from yesterday, you can use the following formula. The following formula is Tn equals to T1 plus n minus 1 d. Wow, so complicated. Some of you actually may know this from your tuition or whatever it is. Some of you learn something different. Tn equals to T0. What is T0 now? Plus nd. Okay, I'll explain both of them. Now the first thing you have to understand is that both of them are general terms. Okay, and again, this is only for common difference. T1 over here is the first term. That is what we know. Plus n. N is this little n over here, same n. Minus 1 is just part of the formula. And we have the letter d. This d represents the common difference. Okay? You probably should write these things down. Now, common difference could be positive or it could be negative. Okay? So 1. When sequence increasing. When the sequence is increasing, like what we have on the board, 3, 5, 7, 9, 11, it gets bigger and bigger. Common difference is positive. Okay? The difference is 2. Look, the difference is a positive 2. The value of d is positive. The other case, when sequence decreasing. When it is decreasing, it tells us that the common difference is negative. When do we see that? Oh, in this particular example, look, it is 38, then after that 31, 24, so on and so forth. It is a common difference of minus 7. Okay, so in this case, the d value is negative 7. In the example on the board, the d value is positive 2. Okay, now, here we have explained the very first version of the general formula, the general term. Tn is T1 plus n minus 1d. If you can memorize this, use it. Go ahead and use it. So I'll show you how to use it for this particular example. Example number 5. The first term is 38. The common difference is 7. 38, common difference negative 7. Substitute inside here. Okay, so T1 equals to 38. That is my first term. Then I plus n minus 1. The common difference is negative 7. Okay? Moving on, we have learned that we can expand 38 plus negative 7n. Plus a negative 7n is the same as minus 7n. Now we see the negative 7n appear already. Next, negative 7 times negative 1 is plus 7. Now we see the 38 plus 7 to give us 45 minus 7n. That is what your classmates have proposed, 45 minus 7n. Now, this is the first method using the formula in purple. T1 plus n minus 1d. Now, how about if you don't want this, you don't like this method, because it involves an expansion. Then I introduce you to another one, the one in blue. Tn is T0 plus nd. No expansion required, but the catch is, you need to know what's T0 lah. What's T0? Okay, so here we have T1, T2, T3, T4, right? If I want to go the other way, can you do it?
Yeah, minus 2.
I think you can. For my example on the board, if this is T1, then what is T0? We go the other way. Minus 2, minus 2, minus 2. And we get 0. Okay? Now, for this particular one, minus 2, minus 2. We get 1. And the 1 is all over here. Okay, same thing on the board. Sorry, on the screen. T0. Now, the number sequence looks like this. 38, 31, 24. So, if I go the other way around, I want to find my T0. This is T1, T2, T3. I want T0. I have to add 7, and add 7 to give me 45. And that's how the 45 appeared. So this will be 45 plus n times of d has a value of negative 7. 45 minus 7n. Okay? So these two versions, up to you which one you prefer. I suppose most of you will actually prefer the second one lah. Okay? 45 minus 7n. So that is for part A and part B. Yes? Haven't finished copying this notes, is it? Okay, wait. Anyway, it's recorded lah. You can go and watch the YouTube video. Okay? Now, one more thing. Are you all happy with my explanation for these two formula? You all happy with that? Are you all able to accept that? Do you have a full understanding of this? Do you all like it when I tell you just memorize and apply? Do you like it? Or do you want to know exactly how we derive it? Because I think that will be more useful for you. Okay? So now, we'll stop.